All right. Well, thank you, Angelica. And thank you, everybody, for joining this webinar, whether it's your morning, afternoon, or your evening. My name is Christopher Upkes. I am a senior field engineer with professional services at Neo4j. And in my position, I have encountered numerous use cases in financial services. I know that the one most of you have heard about or seen marketing on or white papers on has been fraud detection. And interestingly enough, the lion's share of my engagements have not been in fraud detection. And so I wanted to educate you on some of these innovative use cases for graph. And as I go through this slide deck, I have a couple of agendas. First off, every time I've engaged with the financial services organizations, the teams there have, they've had some kind of gap in what they've been able to do in the past and what they're trying to accomplish. And they had a sense, like an intuition, I would say, that a graph solution might be the appropriate solution, but there wasn't real clarity. Not until, I had been finished with the engagement. So every time I interact, there's some education, there's some alignment in terms of like language, setting a glossary, etc. And then I think then finally there was a shared vision. So I want to walk us through that same kind of process here in this next hour. So at first, I want to talk about use cases in general, how all of them apply to financial services in the first place, because you're a business entity. Discuss kind of graph theory and why suddenly this has become, such a hot topic, and then delve into the particular use cases. So we're going to talk about why graphs, what they're used for, graph theory, and the property graph model and what that really means. Practical implementation of graph in the enterprise. Then I got the 3 use cases. So measuring risk in corporate lending from the perspective of a retail bank, very large retail bank. Secondly, understanding exposure to commodities from another large retail bank. And then from an investment bank, predicting the behavior of customers, okay? So why graphs? Everybody understands that things are connected in general. There's an intuition that things are connected. And we store all kinds of data on our business entities. We have it in numerous systems. And we're really, really good at storing sets of information in relational databases or document databases, and we have access to massive amounts of it. Now we've even become adept at storing petabytes of log information with our big data solutions and our data lakes. However, even though we intuit that there's a lot of connections to be understood, we haven't been explicitly storing and exploiting the understanding of those relationships. So of course, analysts talk about this, and so there's buzz. Graph analysis is now the true killer app for big data. A lot of people are investing in graph databases. We're a disruptive technology now. And so that's great. That sounds like a lot of hype, but what does that really mean? Well, let me go through some of the use cases. You should be familiar with some, but you may not be familiar with all, and you may be surprised at what are the most popular use cases, specifically for us in the professional services team. So there's both, of course, internal applications and customer-facing applications. I think most everybody thinks right away when they're dealing with a graph, when they see circles and lines, they think of customer-facing applications that do like recommendations or social networks, right? Well, internal applications are probably more widespread, right? And some of them have a lot less exposure in online and in blogs, etc. Things like master data management. And I'll talk a little bit about those and how I've worked with those in financial services realms. We have all kinds of customers from all kinds of different industries spread across all of these different types of solutions. So we're familiar with all kinds of use cases, and I've dealt with each and every use case across numerous industries. So, of course, the first thing that everybody thinks about is the social network, how people are networked. I guess the history is truthfully that Google and LinkedIn and Facebook and those folks just decided that they'd create their own kind of graph infrastructure. That is not, of course, the background for Neo4j. We started with being an OEM solution. It was designed because one of this kind of generated in parallel, with less the concept of being an infrastructure for a SaaS organization than to provide a persistence mechanism for folks who want to do graph traversals. So that's where we came from, was network impact analysis, and network itself being visualized usually in a graph, with routers and switches being the endpoints, and of course the cabling being the network. I myself has engaged numerous times with logistics and routing companies. A map is a natural graph, and determining route or weighting relationships with duration or elapsed time is kind of a natural implementation of a graph. Recommendations across retail has been one of our key use cases. It's so important that it's become kind of like a standard implementation requirement for the big retail companies as they compete with each other to be more relevant to consumers without having some type of real-time recommendation. Consumers have become so aware of it that if they don't see real-time recommendations, they don't see a relevant experience when they engage with a retail site, they move on. So it's become so prevalent that the big retailers have seen their consumers move from their site to other sites simply because they didn't have real-time recommendations. So fraud analysis, fraud detection, understanding the behavior of your customers, trying to detect structure and connections between behaviors like fraud rings has received the most attention, I suppose, in the media and the folks who blog about this and maybe communicate from inside the industry of financial services. And while that may be the case, it has not been the use case that I have implemented the most. It's a natural fit. I know that it's a big concern. It creates a lot of incremental value being able to understand patterns of behavior. So there's a great deal of value in graph for fraud analysis, and there's been numerous webinars and talks. And so I want to discuss other types of use cases besides fraud analysis and get you thinking like the teams at these organizations were thinking, and specifically about questions that they hadn't been able to answer, that they had an intuition that graph could help them to answer those questions. Access control I've deployed at financial institutions. Identity management and access control is as big a concern, of course, as fraud detection. That is, of course, securing access to information and financial information and other types of critical PII that they might have at the bank or other financial institution. Insurance is just as critical as detecting fraud. And I've implemented this numerous times. If anybody is signed on in terms of providing health insurance and leveraging graph, I've implemented solutions that help to discover or connect data points from claim lines directly to previous fraudulent claims in real time. What that does, of course, is allows them to deny a claim in real time if it's there's some suspicious connection between a new claim and a fraudulent claim versus going ahead and paying that claim and then at a later date having to go to court, right? Which is a lot of cost. It's better to deny the claim than prosecute. So the assumption is that for all these use cases, leveraging graph technology is somehow creating an advantage. It's doing something that we weren't capable of doing in the past. There's some innovation here that has occurred just recently that is, unlocking all kinds of new insight. That's the claim, and it's true. And I just want to make sure that we're all aligned and we understand what that means, because it may not mean what you think it does. So we're going to start with graph theory really quick and see what that has to do with Neo4j and solving, financial use cases. All right. So graphs in general. Graph theory began in the 18th century with a mathematician, Leonard Euler, who decided to solve this age-old problem where people come into Königsberg, beautiful little city, park their bicycle at one end of the city and ask a local, hey, you got all these bridges. Can I go ahead and is there a way for me to cross all these bridges just once and get back to my bicycle? Because that would be great. It'd be great if I didn't have to traverse one of these bridges twice. And nobody could answer that question. So being a mathematician, you want to simplify, eliminate the unnecessary information, break it down to its basic parts, which became a graph. Yes, it's circles and lines. And in doing so, he discovered that he was simply trying to solve a problem, a tour problem. This is it. All right, so is this a Eulerian cycle or Hamiltonian cycle? That means, is it possible to traverse all the edges of the graph exactly once, starting and ending at the same vertex? And I'll talk about those two concepts. Or is it a Hamiltonian cycle? And it turns out that it was not possible. So it took a mathematician and lines and circles to finally ask this age-old question. And now, of course, if you go to Königsberg, everybody will tell you exactly that answer. So we should be thinking, how can that possibly be of value to us? There's all kinds of graph types that have been used in the past, whether this is a simple, a multigraph, a pseudograph. These are probably pretty meaningless to you. That would be my guess. And they're definitely meaningless to a business stakeholder, circles and lines. However, a lot of people talk about it as if it's all about circles and lines. So what's the deal? So what's all the fuss here? You're going to use vertexes or vertices and edges to solve my critical financial business problems. So a vertex, it's a point where two lines meet. That's all it is in a simple graph. And an edge is just a line that joins to form vertices. Okay? That's a graph. We get tons of value out of graph in the networking world. There's a protocol called spanning tree. It protects networks from packet storms, so that if you send in information on a network and there happens to be a loop that's put in there accidentally, there's just not this endless loop of network messaging that goes on forever and ever and ever and shuts down your network. And it's done using a graph, and it has been forever. Okay, that never required a native graph database, and it's because it's largely just a mathematical concept. It uses a small amount of data. Basically, it could use letters of the alphabet to define unique vertices, and the edges are simply numbers. It can be done in memory. It's not a big deal. So there must be something besides just a graph that requires a graph database and can start to unlock all of this, information that's been hidden and has not been allowed us to answer certain questions. Well, let's think about it. So what if a vertex, this thing where two lines meet, could represent something more concrete? If we could provide richer context? What if that was a customer? What if it was a business, an asset, a fund, a trade? What if we could actually take the edges and provide more context to those? What if instead of just a connection, it's a cash flow, it's a deposit or withdrawal, it's a login, maybe it's some kind of context for meaning between two things. This business borrows from this business supplies to this business. So if that's the case, if we can provide richer context, then maybe we can derive more meaning. And we understand that this context has existed in our data all along. However, we've never really had a way to canonize this, to actually grab this context, apply it, and call it at will. So what if I could view all of my business data as a graph and take information from my source systems, right, pull it in and understand the context of the relationships between these things? Now, that requires something more than just a simple graph. Enter the property graph model. This is the reason people use a native graph database. Leveraging a property graph is what these innovative financial institutions have been able to do to answer questions that they've never been able to answer effectively. So what is a property graph? Why is this such a big deal? A property graph has nodes, relationships, properties, and labels. This is providing all of that context. It's taking all this legacy data, all this source data that we have, describing things like our customers, businesses, assets, stocks, accounts, and distilling that information, providing that rich context to a graph so that we can understand the structure, the relationships they have to each other, et cetera. So these complex graphs, they have direction for the relationship, which provides even more context. And with the property graph that's directed, I have all kinds of rich contextual information that, along with the traversal, provides me insight that I've never been able to take advantage of before. It's one thing to draw it on a whiteboard, but if you're talking about the information that a bank has on hand that it needs to understand, that'd be a gigantic whiteboard. So now that I have a property graph, nodes can be all kinds of things. I can label them, I can categorize them. I can provide type and direction to my relationship, which is deep context. It provides a lot of understanding. And with properties, that provides even more context. I can make decisions on them. It tells me, well, I can be very specific about the context for my graph. It's this customer in particular. It's this business. I know I have millions of customers, but I want to understand the relationships based on this particular business, this particular asset, and this particular customer. So with that understanding, that's where we come to the point where somebody from Neo4j, like in professional services, engages with somebody at a financial institution where they had the feeling that if they could go ahead and apply that graph lens to the data that they had on hand, that they could answer some of the burning questions and address some of the critical problems that they've had in the past and cross that gap. So we're going to talk about commercial lending risk management. So this is a very large bank, and a very large bank, it's doing a lot of commercial lending. And when thinking about lending, of course, you have to be concerned with risk. So there's like, I got this, out of like the ABCs of commercial lending risk. What do you do? The 5 C's: character, capacity, capital, collateral, and conditions. So what I tend to see everywhere I go is there's a lot of measures. The financial institution has been around a long time. There's a lot of focus on risk, tons of smart people. And primarily it's all about the data points and semi-additive and additive data. So you have systems that, can pour over a lot of data, right? Do a lot of adding, doing a lot of averages. You have history, so that's fine. You can take a look at history. That history doesn't have to do with relationships. It's just looking at sets of data in time. So you're really good at the numbers, and you use that to define risk. Well, there's one other problem, right? We need a better understanding. This is their problem statements. So we need a better understanding of the business community my apologies, to understand how business relationships are affecting loan risk. So when I engaged, the team was like, so here's the deal. Okay, so we're a big bank. We have kind of standard practices for how we identify risk. We have all this information. We use, detailed information. We have an analyst to go over, and we decide this is the risk for providing loan, the credit risk for this particular loan for this particular business. But there's one thing that this bank struggles with that is apparently key to understanding risk. Knowing your customers and the markets in which they invest are 2 of the simplest and most basic tools of understanding risk. Living, working, and playing in the same community as your borrower is a surefire way to know their business environment. Well, that's pretty hard to do when you're a large institution, to live, work, and play in the same community, to understand the community. And that's the key, is the community. And that's a design pattern in graph. And what is a community, right? It's understanding those businesses, those entities that are all related in some way, shape, or form. It's not just location, right, that defines a community. It's relationships that define a community. So here's what we did, right? To understand this, we wanted to understand, how we just did it basically on the cash flow. So these business entities had payments and receipts from other business entities, all with varied credit ratings, essentially. So this information had always been in there, right? And so it's pretty straightforward, it seems. It's like, well, we know that this business, paid money to this business, and it has this credit rating, and this business, paid to this business, so on and so forth. So row by row, it seems like pretty straightforward. You should be able to take a look at this. But in fact, what it is a community or an ecology of businesses where cash flows between them. Okay, they're all related in some way. So they could be a set of wholesalers and retailers, and to get their product to the end consumer, which is not shown here, they all have to work together to get this done. And that means that there's dependencies. So there's the concept that inside of any particular business community, where you stand, or the risk that you pose to a lender should also be factored by your community. Okay, and so what they wanted to do with the graph is to be able to identify these business communities and how they're dependent on each other. And you can see that we want to also weight these relationships by the actual kind of throughput, like exactly how much money is, exchanging hands between these businesses, because that's important as well. Understand the community and see if indeed there's a case that the risk propagates throughout the community. And I can't do details here, and that's not what this is for. But the fact is that they had a great understanding that relationships had a huge impact, or should have a huge impact, on how they perceive risk, and might be contrary in some cases to what they had. We have cash flowing from, like, say, wholesalers to retailers, and they partner with each other. I don't know the details of why they would buy from each other, but this is the case. Some had a moderate credit rating and some of them had good. And at first glance, the business that we're interested in, or is asked to loan some money to, has a fine credit rating. But now what the bank can do is take a look at their immediate community, understanding all the risk involved, and see how that might propagate. And so by understanding who that they're working with, who they get their supplies from, and all of the subsequent credit ratings, they can see how that risk flows through the community. And in fact, because of the nature of the community of this particular business, it's actually a moderate credit risk versus a low credit risk. And they had never actually explored this or understood this prior to getting into the graph. There were far too many transactions, and they were thinking transactionally. There were far too many little the businesses that they're working with, and it was very difficult for any particular moment, anchor on the context of a particular business, traverse out to all of the dependent businesses that we describe as its community, and then actually view the propagation of risk. Now, there was a bunch of side effects that occurred from understanding this information that were very interesting. So they came up with this concept of a business risk flow. And that meant that, like, how committed you are to this business. And if you really want to understand the business's community, you need to have an understanding of where you can make the biggest impact, or the biggest impact might come from. And in doing so, they could say, well, in this particular community, these are the critical members. These are the foundation of the community that go through this flow. And it did a couple things for them. They could make decisions. They could decide based on the overall health of that community that maybe they want to invest or assist other businesses in the community to bolster the other businesses. So they could walk through, analyze all the businesses that were critical to the flow, and determine whether they want to invest in them, see if they wanted any loans, so they could ensure, because they have a lot of risk exposure, to see whether they wanted to bolster this community. And this would be the most practical way to do that. So not only was it a way for them to identify risk, a better understanding of risk, they also have calculations for like what percentage of overall value in the community each business had. But they could also say, hey, we have a strategy actually for assisting this community and strengthening all the businesses, which had a lot of resonance with the actual community associated with the businesses. It was a good PR thing for this particular bank, it's a very large bank. All right, so that whole paradigm of just understanding the connections, and this was just one type of connection. They weren't really interested in anything but the flow of funds. That was their primary use case. They weren't interested in any other kind of context. And of course, they had to run it and do some analysis and see how these things panned out. And they're in production, and these things actually turned out to create a lot of value. And it's great to see that there was two types of value that they achieved. One was addressing the direct problem, and another one was a side effect, and that was preventing risk through bolstering a community and supporting the businesses in an effective manner. You don't want to just pour money into the business you are focused in, because you might, it's in a sense having the tail wag the dog, when there's other essential businesses in the community that maybe what they do need is a little cash flow that would strengthen everybody across the entire community. All right, so this is a use case that is similar, and it's because you kind of understand, once again, you have to understand the community, but it was all about exposure to the volatility of a commodity. Okay, so this was like, I think in 2016. You have about $100 billion in credit exposure for Canadian banks related to the oil industry. Okay, so the burning question was, how do we understand, whether a business is going to be affected by volatile oil prices, right? We need more ways to determine our credit exposure to commodities and oil in particular. That was the basic question. So obviously commodities impact industries you might not expect. Do you know all of your customers? How are your customers connected directly or indirectly to the oil industry? And how will a precipitous drop in oil prices affect the businesses that you invest in or provide credit to, right? All right, so how do we go about doing this? So once again, business, function, and community are related in different ways. So they had all kinds of information on their customers, all kinds of loan data, all kinds of data describing the customers in depth, how they're structured, because these people come from loans, they have to know everything about them. They have all this transaction data. They know how these things interact. I mean, they were telling me things like, yeah, these two, businesses co-borrowed a loan. This business has a loan and they lent money to this business, so they know how all of that works. And so what we did was take all this information from these different sources to help us to build a business community graph that had the right kind of context to help us solve the problem. So kind of the big thing was making sure, because we didn't want to leave any relationship unmined. There's all kinds of relationships between business entities, and they had to be kind of either inferred or directly extracted. I didn't know there was this many, not being directly from the financial services world, being in the software world. But there's like, and you can, it's the semantics are pretty important too if you're going to think about doing this. There's lends to, owns part of, co-borrow of, subsidiary, supplies to, provides services to. You can flip it around instead of saying supplies to, saying, you know, get supplies from or require services of. However, but all of these mean that they need to be in the community. If you're wondering if this business A is related to business B, if any of these are correct, then it is part of the community. And that was the important piece, was to say, is there any context for which these two business entities are related? One being in the oil industry, right? These folks build drills, you know, or pumps. And, you know, this is a company that, you know, works in the civil sector and, you know, helps to build hospitals or something. Those turn into relationships between entities. Company A lends to Company B owns part of Company C. So if you just had a huge table with all these relationships, that you're kind of only part of the way there. It is really, really tough to see. If you see a direct relationship between a business and the oil industry, that's great, but you would have already found that anyway. It's these obscure relationships or circuitous relationships that might be hiding some kind of exposure. So we get all those types of relationships, put them in there. It is important to understand the context because there's weight related specifically to these different types. A supplies or a lends to might have more weight than some other type of relationship. And that's based on your particular business case. So here we have, after we figure out all the relationships, they're basically connections and they can be weighted. And no different than the this other bank's view, everybody had a credit risk. Everybody has that. That's what happens in commercial lending. So on one side, you have your industry specific, you know they're part of the oil industry. You know that regardless of their credit rating, something drastic could happen and oil prices could skyrocket or plummet, and regardless of their health, you're going to need to go back and address their credit rating. And then you have other businesses that were part of different industry codes, clothing, manufacturing. There's a bunch of interesting codes, right? Selling mayonnaise or something like that. So you have all kinds of different business codes and they're not directly related, so they're not going to pop up. However, they're part of the community because they happen to be connected to the oil industry via a single business entity that's part of the oil industry and does something that is foundational. I don't know, machines parts, provides labor, something of that nature. And so by doing this and by understanding the relationships between that particular connected, able to track essentially impact, right? Potential impact of business entities that seemed completely unrelated. So you had weights that would be like, well, this one actually lended to this business and has a lot of investment in this business. So if it, the one on the top here, so if it tanks, if there's something that negatively impacts because you have the factors of propagation of risk just by being in a community, and then you have this cross-pollination because just by being in the oil industry, your credit rating could, change. The health of the company could change overnight. We realize that we have much more exposure than we thought we did. If it was a total of 5 clients in the portfolio, we got 1, 2, 3, 4, 6 clients in the portfolio. The truth is that we likely have a lot more than we thought we had. So if you calculated it directly as 100 billion, is that really the case? And the fact was, for this particular bank, that it was pretty eye-opening when we actually built the graph and understood just how much impact, and this happened to be, you know, in Canada, just how much impact the oil industry has on in huge communities of businesses, how it's, you know, interwoven into everything, especially in some parts of the nation. And it's, you know, it's probably a gross understatement what has been said about exposure or credit exposure to the oil industry, because of its massive effect on other businesses in the community. Okay, for time, finishing up, and then because I want to make sure you get at least 10 minutes here. So the last customer is an investment bank, and a very interesting use case. So underwriting, if you just for your edification, underwriting for investment banks is assuming a risk on the behalf of an investor selling securities in the stock market. So what happens apparently is that an asset manager says, I got to sell a lot of this stock right now, and the investment bank says, okay, so underwrites it, has it there, and then has to go find buyers. And if they're not prepared or they can't find the buyers, it's a loss. Okay, so being caught off guard, not being prepared, not having a great understanding means that there's greater risk that the investment bank is going to lose on this transaction. So the problem statement: we need to be better prepared to support our customers' trades so that we are less likely to suffer loss. To do that, we need to better predict when and what our customers likely want to buy or sell. Well, that seems pretty straightforward. Okay, so I show up, I'm like, hey, let's do this, let's get all the information, we'll look at patterns. And here's the problem, is that, and it probably is endemic, is that this particular investment bank, all of the internal systems, it's anonymous. I mean, there's some names and stuff, and the only thing they deal with that's standardized is like the ticker symbol, the amounts, dates, etc. So internal systems don't represent reality. So there's all kinds of publicly available information, but that publicly available information is not represented internally. So there's no way to say, well, here's what we know happened on our side, and see all this behavior. We don't want that to happen again. So who are these people? So if we're going to try to do predictions, there's a couple of problems. First of all, we have no idea what real fund or whatever it was on the other side. So we can't tell who's making the calls. And if we can't tell who's making the calls, there's no point. We're never going to be able to predict anything, because the asset managers have a certain style. They do things a certain way. They can prove this, but they just can't match it up. So what did we do? So this is just a link analysis pattern from Graph 101. So we have externally public data. This, I've seen it. So you have data that gives you like business entities, and some I don't know, Fidelity, and they have these funds. So you have these funds, and these funds have an asset manager that goes ahead and does trades, buys and sells these things to maximize the investment of his customers. And so you have this information, you have these transactions, or a particular asset on a particular date. You have other types of identifying information. They all exist in the graph. And then we need to load all the internal application data. And what happens is these things match up. What happens is you find links between the two. So I can traverse from this internal customer ID with, let's say, specific bits of PII with transactions that match the same symbol. They can traverse from a symbol on a date with amounts to information that's collected externally that helps to go ahead and clarify. So by combining these two and doing traversals and using link analysis, the investment bank is able to say, I believe, with some deal of confidence. It's analog, it's not binary. It's like the 80% confidence that all these transactions, all these things that happened were for this balanced fund that was managed by Jane Doe at Trans Capital, who's moved on to somewhere else and is doing a balanced fund as well. And now that we've seen what Jane has done in the past, and we really know that, we can predict that, she's probably going to do some of the same things again. And we'll be better prepared. If we have to line up people, she's going to, buy this, and then she's probably going to drop this kind of stock. It's going to be in this industry. We're going to line people up. We're going to be prepared. And that was the agenda, the entire agenda for that particular team. I thought it was extremely innovative. They didn't understand that it's called link analysis, and it's something you do for master data management, customer 360. It's super common, okay? And this is a very innovative way of doing so. And it's low-hanging fruit, and it's a very tactical thing. And they discovered all kinds of other strategic applications for doing just this. There's always a reason for you in financial services to be able to have a holistic view. In this case, it's a holistic view of a customer, and that customer is an asset manager who you underwrite the sale of stocks for, okay? So I tried to do it just in terms of 10 minutes left. I know that's pretty high level. I just wanted you to see if you could start thinking like these folks were thinking. I thought they had some great insight. They had very practical problems. They weren't, I need to know fraud. I need to understand fraud. They were very specific. And graph is best implemented when you're trying to solve a very particular problem. So I hope that helped. It's hard to articulate in an hour and make sure you get background, but I tried my best. And I'll leave the last few minutes or so of the webinar for any questions that you might have.
Yeah, thank you so much, Chris. That was really cool. So a reminder to everybody, if you'd like to ask Chris a couple questions, we do have about 10 minutes left. So there's a questions box on your GoToWebinar control panel where you can type those out, and I'll read a few live. So to kick us off, we have a question here. So Chris, could you describe the difference between link analysis and impact analysis? Is that the same problem statement?
Yes, it's not. So that's a great question. When we're doing link analysis, we have a different kind of measure. That's a great point. I'm going to add that to my slide next time. It's a different kind of measure. So what we want to do in link analysis is what's valuable to us is the number of links. So if we're trying to match up an internal customer with an asset manager, it's the number of links and the weight both that determine whether we think that we have a match or not. So we collect them. So we have like, okay, they were linked 5 different ways, 20 different ways. We could traverse from here to there across 30 paths. And the weight for these paths are such that we can add them up, and it's an overall weight of 50. I could also potentially attach it to something else, but the weight is only 20. So it's all about the number of paths and maybe summing the weight of the paths. Impact analysis really is about, can I traverse from point A to point B, right? So am I impacted? Is there any way I'm connected at this end to anything else on that end? Is there any way? Yes, there is. That's impact analysis. Is there any way I can avoid it? Can I reroute it? So that's kind of the distinction between the two. One is, there's value in the number and weight of paths, and the other one is there a path or not? Okay, next.
Great. So is there a software to do an easy visualization of Neo4j in different websites?
Is there? Well, there are numerous visualization tools that don't show circles and lines. That's not what stakeholders want to see. That's what graph people do to just validate their theories. So, we have Link Curious. I think there's key lines. You might want to, we put links to that or something. And there are libraries that, like D3, that are very specific to ingesting information and presenting it kind of in a graph format where you have icons and they have some kind of something that connects them, right? And or they can take graph information and present it in a meaningful way. And some, you may measure like the number of connections or number of links. You don't want to show links. You might show it as, another visual, like this is the entity most likely, and it could be just avatars of people in different sizes or something. So we can provide, links to those. So Link Curious, key lines, like the D3 libraries. Anything else?
Yeah, definitely. So maybe a bit more of a technical question. Is it possible to control security down to the node level? So for example, could you give certain users access to certain nodes, but not other parts of the graph?
Yeah, so we have, typically that was done in your application layer, but we have granular access now so that you can, like, certain types of nodes you can see, you can't see. So we have granular security roles inside of Neo4j that allow that. So, if you had some nodes that you want PII on in your graph and you're like, no, only specific people can see that, yeah, that can be done without any other tool but Neo4j.
Okay.
Next.
Yeah, so in your experience, are clients typically able to maintain and query graph applications on their own, or how could they leverage consulting services in a sense? We assume that you would require a basic knowledge of Cypher and data modeling in order to implement Neo4j.
Yeah. So the biggest problem I've had in the past with making sure that, there was people had momentum was that they really understood graph. So the first thing is you need to be adept at solving graph problems, right? You're like, I understand that understanding community businesses and how they interact and what that means is all about a graph of businesses. And that's what I do. And once they've got that down, everything is pretty straightforward. The only time people have issues with applications or scale is when they don't really think in graph. They have maybe a spot problem. They had a tactical issue, like with a relational database, and they just said, I need to switch to something else. But once they'd decided that they, along with other things, that they would, they needed to commit to understanding how to solve problems using a graph, they were fine. Typically, for organizations, it's what happens is that the requirements start to bloom. People start to get it. There's new requirements. And so we kind of engage, I engage kind of in time slices to go and just make sure that certain milestones are achieved. And that's what I've seen in terms of, especially financial institutions. It just has certain milestones. I just want to make sure this is production ready. We're going to get a lot of hits. Hey, I got these new requirements. Just want to validate. So those kind of things, pretty minor.
Yeah, that makes sense. And to implement Neo4j, is this kind of a rip and replace solution, or does it work well with other databases? I'm not sure what you've seen out in the field.
Okay, so rip and replace, no. So what kind of data goes into a graph database? Data used to solve graph problems. So if we're going to do the solution for, let's say, corporate lending risk, what kind of information? We need, from our source systems, we need the context that builds a rich, useful property graph. But other than that, we don't need any other information in it. If it's not going to help us to, look at the community, traverse to discover who all is in the community, look at where the money flows, understanding how risk propagates. If the data doesn't lend itself to that, then I don't know why it would be in there. So if you don't have source systems, if it's, if your data entry is going to go right into Neo4j, then yeah, I mean, that's all you need. But likely you have massive amounts of information in relational databases and other things all over the place, and you can distill that essential information you're going to use to solve your problem into the graph. And so it plays wonderfully in a multi-storage environment, this polyglot storage concept, where we work hand in hand with other types of data stores to provide incremental value to close, to cross that chasm that you have, to answer the questions you couldn't do when with the systems that you have in place.
Okay. And I think we have time just for one more question. So how would you suggest to best track changes to the relationships over time?
Great question. So that's very technical. So there's a couple of design patterns. So we have a way to just do, it's a simple design pattern. And I would normally draw it, but what you can do two things is that there can be state information in every relationship. There's no reason you can't do that. You can put it in the type. So you can say this was, their relationship at this date. So like for the oil industry exposure graph, those are pretty static. They might change every once in a while. So just put the date on the relationship or put it in the name. Because we can have one that has a past date and one that's current. And then the other model is a design pattern that we use to just have a time dimensioned graph. And that is that essentially, it's called the observation pattern. And you just say that at a certain time, this is everything I've observed. And so no relationships connect directly to any particular durable entity, like a customer is only in a graph once, right? You don't have a customer multiple times. And so the customer, or let's say it's a business, has a relationship to another business. If you want to time frame it, you can say we observed at this time that this, and that's a node that exists in between. I observed at this time that this business and this business have a relationship. And you always have a most current observation. So we have numerous patterns. They're all very elegant, and the logic is hidden. You typically, the graph that has this concept of observations, those details are hidden because you only care about the traversal from the business to the business and not anything intermediary. It wouldn't matter to you. So I probably should have a webinar on just some design patterns. I do it everywhere I go. So there's never been anybody who hasn't been concerned about time and making sure they track provenance or change.